All right, let's pull back the curtain on cybersecurity. Today, we're talking about how the pros find and fix digital weaknesses before they turn into a total disaster. This is all about vulnerability analysis and assessment. Basically, the art of finding the cracks in the armor before they break.
You could think of it like this: leaving the front door of your house wide open. That's pretty much what a digital vulnerability is. It's just an unlocked door in your software, your network, maybe your apps, that an attacker can just waltz right through. So the whole point of this entire process is to find those doors and, well, lock them up tight.
Now, you're going to hear two key terms thrown around a lot, and it's really important to know the difference. First, you've got vulnerability analysis. That's the super technical part, just detecting and categorizing the flaws. Think of it as making a list of all the unlocked doors you find. But then there's vulnerability assessment. That's where you evaluate the business impact. You ask, okay, so we found an unlocked door. What are the odds someone actually uses it? And what could they steal if they did?
So let's get a really crystal clear picture of the core problem we're actually trying to solve here.
Here's the textbook definition for you. A vulnerability is any weakness an attacker can exploit. Simple as that. It could be a bug in the code, a server that's set up wrong, or even a piece of software that's just old. The whole name of the game is to cut down on risk by finding and fixing these things before the bad guys do.
Right, so professionals don't just randomly poke around looking for flaws. That'd be chaos. No, there's a structured playbook, a systematic life cycle that they follow to make sure nothing gets missed.
And this right here, this lays out that entire process. It's a continuous loop, it never really stops. First up, you've got planning, deciding what you're actually testing. Then comes discovery, where you find every single device on the network. In phase 3, identification, you unleash the scanners to find potential weaknesses. But hey, automated tools can be wrong, right? So phase 4 is verification, where you manually confirm if the findings are real. Next, you rate the risk to figure out how bad it is. And finally, you get to reporting and reassessment. You write up the findings, fix the problems, and then, you guessed it, you start all over again to make sure the fixes actually worked. It's a constant cycle of getting better.
And this isn't just about running some tool and, hoping for the best. Analysts are leaning on a massive global body of knowledge to identify and score these vulnerabilities the right way.
Now, what's really cool is how collaborative this whole field is. It's like a shared intelligence network. At the very center of it all, you have resources like the CVE database. That stands for Common Vulnerabilities and Exposures. Just think of it as a giant dictionary of every known vulnerability, each with its own unique ID. Then you've got the NVD, the National Vulnerability Database. It takes that CVE entry and adds all this crucial context, like severity scores that tell you exactly how dangerous it is. It's really a global effort to arm the defenders with the info they need.
And speaking of scores, this is what an analyst sees. This number comes from what's called the Common Vulnerability Scoring System, or CVSS. It's a standard way to rate how severe something is, on a scale from 0 to 10. A 9.8 like this? Whoa, that's critical. It means it's probably easy to exploit from anywhere in the world. You don't need to trick a user into clicking anything, and it could give an attacker complete control. This is a drop everything and fix this now kind of problem. In a world with thousands of issues, this scoring system is absolutely essential for figuring out what to tackle first.
Okay, so we've got the theory down. Let's actually peek inside the digital toolbox and look at the scanners analysts use to find these things. First up, we've got Nixto. This is a fast, free, open-source web server scanner. Its specialty is doing a quick check for all the common stuff: outdated software, default files left lying around, and other low-hanging fruit that attackers just love to find.
And this is what it looks like in action. It's super straightforward. An analyst just points Nixto at a web address, and bam, it runs through thousands of checks and reports back anything that looks fishy. It's a fantastic first-pass tool, for sure.
But like any tool, it has its trade-offs. The big plus is it's fast and it's free. Can't argue with that. The limitations, though, well, it can be pretty noisy, which means it's easy for security systems to detect, and it sometimes gives you false positives, flagging things that aren't actually a problem.
Now, on the other end of the spectrum, we have Nessus. This thing is one of the most popular commercial enterprise-grade scanners on the planet, and it goes way beyond just web servers. We're talking entire networks, individual computers, and even checking for compliance.
So the key thing to understand about Nessus is its depth. It can do what are called credentialed scans, where you actually give it login details. This lets it look at a system from the inside to find stuff like missing security patches. It's like having the keys to the building versus just looking at it from the street. It also crushes compliance scanning with checks for standards like HIPAA for healthcare or PCI DSS for credit cards. It just makes reporting and prioritizing risk so much more powerful.
And unlike Nikto, which is all about the command line, Nessus is usually run as a service, and you manage it through a really slick web interface. This makes it perfect for scheduling scans, managing results across a whole company, and generating those professional reports for the bosses.
Okay, so you've got these different tools. How in the world does an analyst choose the right one for the job?
This table breaks it all down perfectly. If you look at the focus row, you see Nikto is all about web apps, while Nessus is for the whole enterprise. License-wise, Nessus is commercial. You got to pay for it, while Nikto and another tool here, OpenVAS, are open source. And check out auth scans. Nessus and OpenVAS can do them, but Nikto can't. So, for the best use case, you'd grab Nikto for a quick check. But for serious, deep dive compliance work, Nessus is pretty much the industry standard. It's all about picking the right tool for the specific job you're doing.
At the end of the day, the one thing you should really take away from all this is that vulnerability management isn't a one-and-done thing. It's a constant cycle of planning, scanning, fixing, and then testing all over again. It's all about being proactive and finding your own weaknesses before somebody else does. In cybersecurity, the best offense really is a proactive defense.
So, I'll leave you with a final thought to chew on. In our own digital lives, with our phones, our laptops, our home networks, what's the one unlocked door that we all tend to forget to check? Something to think about. Thanks for watching.